Our solution for transportation problems is optimizing bus routes. So the problem that we encountered and we chose to address was how current bus routes are not adapted for fall semester due to new restrictions and changes to the campus environment brought on by COVID-19. Our solution is to optimize bus routes to meet social distancing and sanitation standards. We hope to present a viable solution for the bus route system and action items to implement it. So the problem that we are currently faced with is that the current bus routes are not adapted to the new requirements and concerns of the pandemic, including social distancing, sanitation of public spaces, and the effect of other systems being altered for safety. We chose this problem as current bus routes have been successful at transporting students between campuses in past semesters. However, they need to be adapted to fit the needs and ensure the safety of our community during the pandemic.
According to the Fall 2019 Transit Ridership Report, Blue buses provided approximately 7.5 million rides during the Fall 2019 semester. This demonstrates how essential Blue buses are to the success of the Michigan community. Okay, so we frame our problem statement using testimonials from expert mentors and transit ridership data. They mention that the current capital plan does not allow for the purchase of additional blue buses. Also, that the school infrastructure and the time frame does not allow for the production of additional blue buses. And we would assume a capacity of 9 riders while maintaining a 6 feet social distancing guideline, and a capacity of 18 riders will maintain a 3 to 4 feet social distancing guideline.
So our solution is to modify bus routes to decrease the complexity of the bus routes and meet the unique requirements of the fall semester. It will allow more time to visit the remaining stops frequently and conduct more runs, effectively reducing the number of people on the bus at any given point. This will decrease both the number of individuals waiting at the bus stops and the number of individuals on each bus. Because simpler bus routes will take less time, there will be a greater number of opportunities to stop and disinfect buses. An example of the route optimization is with the commuter north. So we would consult transportation experts and models to decide route changes and consolidating the bus stops. We would make these new routes then known to the public, and we would also continuously collect data and assess whether the route meets specified criteria.
Okay, so the criteria that we're going to be using to determine success is as follows. The density of people on the bus. So we will have a maximum of 18 riders on a 40-foot bus, and that's ideally 9 riders, or ideally 9 riders. We'll be using the data from existing rider counting system to determine the amount of riders at a specific time. The second criteria is the density of people at bus stops. Social distancing should be easier outside at bus stops rather than inside a crowded blue bus. And we would ask drivers to take a note of social distancing guidelines and whether they were successful. The third criteria is the frequency of route completions. So ideally, we seek to increase the frequency of route completions, and we will determine whether we were successful in doing this by using the bus route data log. The final criteria is the user input. We seek the approval of bus riders, and we will be receiving feedback from them by emailing surveys to students and faculty, and to access their user experience. And this concludes our solution. Thank you for your interest and our solution.